Hello and welcome. In this video tutorial, we're going to help you be able to calculate the speed through PhotoGate A, PhotoGate B. We're also going to help you be able to scale your time axes in your position and velocity axes. Once we do that, we're going to practice plotting our points, making our best fit curve and best fit line. To finalize things for the bottom graph, we will find the slope of our best fit line. And the slope of that best fit line is going to be equal to the acceleration. So we'll get to that part soon enough. First, let's make sure we understand how to calculate our velocities. So my first velocity is VA, okay? And it's this value right here, the velocity through PhotoGate A. And how I do that is I take the length of my car. Now my car was 7 centimeters long. So if I take the length of that car, 7 centimeters is 0.07 meters. And I divide that by 0.1419, 0.07 divided by 0.1419, I'm getting 0.4933. So I just rounded that to 0.49. Now to get VB here, I take the length of my car divided by TB. So if I take 0.07 divided by 0.0531, 0.07 divided by 0.0531, I get 1.318. Well, I'm just going to round that up to 1.32. And so I keep repeating that. 0.07 divided by 0.0597 gives me 1.28, and so on. So if I take the length of my car divided by my time through PhotoGate B, I will get my speed through PhotoGate B. At this time, go ahead and pause your video and finish calculating the rest of your speeds. All right, now that you have your speeds plotted, we need to scale our axes. That way we can plot our points. Let's actually start. If you notice, the top graph is going to be position of PhotoGate B versus time between the photogates A and B. TAB is the x-axis for both graphs. So let's scale that first. Notice my largest TAB is 1.52. Now, some of you may have one that's a little bit longer than that, maybe about 1.77 or even upwards of 2 seconds. Well, you got to scale it according to your largest value. So for me, 1.5, that allows me to scale my x-axis kind of like this. Let me see, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'd be 1.0. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, that would be 2.0. And I don't need to label it any more than that. Now, since my x-axes are both TAB, I'm just going to copy that same scale down here. Right there. Okay, so both my x-axes are good to go. Now, my y-axes are going to be position of PhotoGate B in meters for the top graph and velocity through PhotoGate B for the bottom graph. So I got to scale each one of those. Now my largest position data is 2 meters. So I actually counted ahead of time, and there are 19 boxes that go up the graph paper. So what I could do is I could make one more box, a 20th box, and that would take me right to 2.0. It's kind of like this. 1, 2, 3, 4, 5. That'd be 0.5. 6, 7, 8, 9, 10, right? That'd be 1.0. 11, 12, 13, 14, 15, that's 1.5. 16, 17, 18, 19, and then that would be 2.0, okay? And I can get away with that because it's only 1 point off the graph. Any more than that, not a good idea to do that. You have to rescale it to another value. Maybe instead of going by 0.1s, you'd go by 0.2, right? 0.2, 0.4, 0.6, 0.8, and so on. So your scale is going to be dictated by the points that you have for the largest value of your data. for my largest velocity, you can see is about 2.22. So for that one, I don't have 22 boxes going up this thing, so I'm not going to use the same scale. For that one, I am going to go by 0.2s. So 0.2, 0.4, 0.6, 0.8, 1.0. 1.2, 1.4, 1.6, 1.8, 2.0. Okay, 2.2, 2.4, 2.6, 2.8, 3.0. I don't really need to label anything beyond that. That's good enough. So in order to graph, you must scale your axes first. Okay, now we're just estimating plot points. I'm going to choose a different color to go ahead and do that. The very first plot point I'm going to do is this value right here. And that's the position of photogate A, which is at 10 centimeters or 0.1 meters. So I'm going to go to 0.1 meters on my graph, and I'm going to make my first dot. That first dot right there is the position of photogate A, which never moved, stayed at 10 centimeters. The other 16 data points are going to be going over this amount and going up this amount, okay? Let's do it one at a time. My first plot point, I'm going to go over 0.55 and then up 0.5. Well, 0.5 is here, 0.6 is here, 0.55 would be halfway. So I'm going to go over 0.55, up 0.5. There's my first plot point. Again, if you need to see anything again, pause or rewind the video as needed if you feel like it's going too fast in real time. My second point, I'm going to go over 0.65 and up 0.6. So over 0.65 would be there, up 0.6 would be right there. My third point, I'm going to go over 0.73, that's a little beyond 0.7, and up 0.7. That would be right there. My next point, I'm going to go over 0.8, up 0.8. That would be right there. Okay, then I'm going to go over 0.85, or 0.86 rather, and up 0.9. That'd be right there. Then I'm going to go over 0.93, up 1. That'd be about right there. Then I'm going to go over 0.99, up 1.1. About right there. Then I'm going to go over 1.07. Now 1.07, actually that's 1.076. That's really 1.08. So 1.08 is just a hair to the left of 1.1. So go over almost to 1.1 and then up 1.2. So here's 1.1. We're going to go a little bit to the left of that and up to 1.2. That would be maybe about right there. Okay, then we're going to go over a little beyond 1.1. So 1.12 is a little beyond 1.1 and up 1.3. About right there. Then I'm going to go 1.19. That is just a hair to the left of 1.2, up 1.4. That would be right there. Okay, my next data point is going to be, where am I at? 1.1. Okay, we're going to go over 1.25 and up 1.5. So 1.25 is halfway between 1.2 and 1.3, and up 1.5. Then I'll go a little beyond 1.3. 1.32 is beyond 1.3, and up 1.6. About right there. Okay, then I'm going to go over 1.24. Notice my time kind of backtracked a little bit. That tells me this is probably, these 2 points rather, are probably going to be outliers, and that's okay. They happen. 1.24 over and about 1.7 up. So 1.24 over, 1.7 up, puts it about right there. Okay, and then we're going to go 1.28 over and 1.8 up. Now we're back over here. So I've got a few data points right there that are kind of off the path. The path is right here. Okay, I got 2 outliers right there. That's okay. It just means I'm not really going to include them in my best fit line or curve. And this time I should have a best fit curve. And next I'm going to go over 1.33, up 1.9. That puts me back on this path over here. And then finally, I'm going to go over 1.52 and up 2.0. So here's 1.5. 1.52 is just a little beyond that. And then 2.0 is right there. So it's kind of like right on top of the B. That would be a good place to plot it. Okay, now in order to plot your best fit curve, now it's not a best fit line, because if it were, it would be going right through here, and that doesn't really make a whole lot of physical sense, especially when you started from that point right there. At this point, take your graph, turn it upside down so that you can use the heel of your hand as a pivot point, and then just draw a nice best fit curve that goes through those data points leading all the way back to there. That's probably the best way that I found to construct a good best fit curve. And that's all you need to do for graph number 1. Now for graph number 2, okay, we need to get your data points plotted, okay, for going over TAB and up VB. I'll use a different color to plot those. Now my first value is going to be the speed through photo gate A, which is actually going to be that point right there, 0.49 at time equals 0. So at time equals 0, 0.49 is just a hair under 0.5. So I'm going to plot a point right there. Then I'm going to go over 0.50. And then that should be 0.55. And then up 1.32. Okay, so here, every box is 0.2. So if this is 1, this is 1.2, 1.4. So 1.32, 0.2 probably about right there. Okay, then I'm going to go over 0.65, up 1.28. Okay, then I'm going to go over 0.73, up 1.36. Okay, then I'm going to go over 0.8 and up 1.4.5. Then I'm going to go over 0.85 or 0.86 rather, and up 1.77. Be about right there. Okay, then I'm going to go over 0.93, up 1.67. About right there. Then I'm going to go over 0.99, up 1.93. That's almost 2. That would be about there. Then I'm going to go over 1.07. That's a little bit almost to 1.1, and then up 1.72. Okay, then I'm going to go over 1.19. That's almost to 1.2, and up 1.88. All right, then I'm going to go over 1.25, up 1.96. Be about right there. Then I'm going to go over 1.33, up 2.24. About right there. Then I'm going to go over 1.24, up almost 2.3. Be about right there. Now it's kind of almost like it's working backwards. Well, it's not that it works backwards, that's that's an outlier point. Then I'm going to go 1.28 over and 2.09, that's almost 2.1 up. About right there. Okay, then I'm going to go 1.33 over 2.17, almost 2.2 up. And then my final point is I'm going to go over 1.53 and up 2.22. Be about right there. Okay, now my points are somewhat linear. You can see the line that would pass through there. So you want to line up your y-intercept, your first data point. This first data point, just so you know, this is the velocity through photogate A. That's the initial velocity the car experienced. So I'm going to line that up with the rest of my data and a ruler. Go get a ruler. And it might look something like this. That's a pretty good trend of your data right there. At this point, go ahead and find two convenient points that allow you to calculate your slope. I like that point a lot right there. And if I keep going up my line, I like that point a lot right there too. So go up and over. Remember, you're not calculating the slope of your top graph, just the best fit curve on your top graph. You are calculating the best fit slope on your bottom graph. Now for me, my rise is 5 boxes. You got to be careful. 5 boxes is not 5 boxes necessarily. On my scale, it's 1.0. So my rise is actually 1.0. My run is not just 8 boxes. 8 boxes on my scale is actually 0.8. So my run is actually 0.8. So to finish off your lab, this is all you have left to do. Go ahead and write A for acceleration equals slope. This tells me that you are matching the concept with the application. Okay, that's that you understand what slope equals in this graph. In this graph, slope is the acceleration. Now, that is of course equal to rise over run, which in my case is 1.0 meters per second over 0.8 seconds. For you, go ahead and put in your rise and your run so you can figure out your slope. So 1.0 divided by 0.8, I'm getting 1.25. So that's where we're going to write whatever your slope is in decimal form, and make sure you include the units for acceleration. All right, and that's what you need to do to finish your acceleration lab. So what did we work on today? First, we need to make sure that we can calculate the velocity of A, the velocity through photogate B. We need to make sure we can come up with appropriate scales for the time axes and the position and velocity axes. We need to make sure that we can plot our data points effectively and be able to draw a best fit curve through the top graph and a best fit line through the bottom graph. Finally, we conclude this by finding the slope of our best fit line on the bottom graph and know that the slope relates to the acceleration of the graph. I hope that helped you be able to finish your acceleration lab. If you have any trouble putting the final pieces of it together, please make sure you come and see me. Thank you.